This is Milani. Chapter 13, Section 2, Problem number 2. In this problem, we have to find the critical point, increasing, decreasing, relative mean, relative max. As I talk about it, I combined 13.1 and 13.2. Then this way, you are going to be able to see more examples. The first thing is domain. Here I have a rational equation. Rational equation domain is everything except the value of the denominator, which is 0. Then, to find the critical point, I have to find the derivative of this one. But you can get the derivative several ways. It doesn't matter for me as long as your way is right, we get the same answer, that will be fine. In my PowerPoint, the first thing I did, this part, I wrote it as a x to the exponent minus 1. And now, from here, I'm going to get the derivative of these two terms. Derivative of x to the exponent 2 is the 2x. Derivative of a minus 1, move the minus 1 to the front, and then you are going to subtract the 1 from this minus 1, which is become minus 2. Now, if we are not going to have a negative exponent, definitely it will make it easier to work, and we know we cannot have a negative exponent. Then, get rid of the negative exponent and move the x to exponent 2 as a denominator. Then, this is my derivative. When you are trying to find the critical point, the easiest way you can do, you can set your derivative for this part, your choice. You can subtract these two from each other, get the LCD and set just the numerator equals 0, or right here, I set the whole things equals 0, but here I have a 2 terms. I'm going to move this one to the other side, and 2x, I'm going to write it down as a 2x over 1. Then from here, you cross multiply. That means 2x times x to exponent 2 is become 2x to exponent 3, and 1 times 1 is going to be 1. You are trying to solve for the x. From here, divide both sides by 2. Now, you have to solve for x, get the cube root from both sides. And now, this one, you just plug it on the calculator. Cube root of a 1/2 is going to be 0.79. But at this time, the first thing I did, I actually simplified this by this, which is x is equal cube root, which now I'm going to show you x is equal 0.79. This is the x coordinate for your critical point. To find the y value, you go to the original problem, replace your x by 0.79, means find answer, but you recalculated at home. Then, critical point, the x is 0.7 and my y is 1.89. Now, we need to find the increasing, decreasing. In order to do that, the first thing I do, I'm going to draw the line, and then I will label my x coordinate for critical point. And I'm going to just plot the point because my y value is going to be positive number. Then, I'm going to make a table. In my table, this is the first derivative table, which from here, I'm going to do my testing point for increasing, decreasing. Now from here, Don't forget, my critical number is 0.79. I have a one critical number, means I'm going to have two testing points. The left side, pick any number. Remember, you cannot say f prime of a 0 because 0 is not in your domain. Then I'm going to say f prime of a -1. And then pick a number in the right side of the 0.79, which is f prime of a 1. Now, in this one, it does make it easier if you are going to have actual number. If I replace the x by -1, it's going to be 2 times -1 is going to be -2, and replace this x by -1. -1 to the exponent 2 is become +1. 1 over 1 is going to be -1. Then -2 combined with -1 is become -3. Now, replace the x by 1. Then here I would get 1. Here I get the -1, which is going to be 1. Now, the main things we concern at this time, if my answer is negative, that means in this area, my graph is decreasing. If my answer is any positive number, then in right side, my graph is going up. Then, I'm going to draw my line. Left side is going down, right side is going up. Now, from here, to find the increasing, that's this part is increasing, which is from 0.79 to positive infinity. Decreasing is the part of the graph which is going down. Then this is the part is going down, which is in the left side of the 0.79. But don't forget, domain. Domain cannot be equal 0. Then relative max. Relative max is going to be increasing to decreasing. I do not have it, which is going to be none. Relative mean, decreasing to increasing, which is right here. X is going to be 0.79 and my y is 1.89. And that is the end of this problem.